Pretty thighs, shawty, she a dime. Demon girl, evil eyes, she be telling lies. Slim waist,
Pretty gonna move a bit on what you're doing right now. So you're currently developing the interplanetary internet system. It sounds kind of cool. It's a prototype called Delay Tolerant Networking. It's currently tested on the ISS to potentially bring the internet to Mars. Now, once again, humans haven't been to Mars, but Elon says we're getting closer to it. So what made you want to get involved in this project, and why haven't Martians already developed the internet on their own?
Okay, well, let's see. I got really lucky. Remember, I mentioned a company called North American Aviation. I got a 4-year scholarship from them to go to Stanford University. Well, just after I graduated from high school, I had a 6-month gap before I went to college. One of the companies that was part of the North American Aviation complex was called Rocketdyne. And in the 1960s, they were building the rocket engines that were part of the Apollo program. So there was a big booster called the Saturn V rocket. It had 5 of these F1 rocket engines, each of them generating 1.5 million pounds of thrust. While I was just graduating from high school, I got to help test those 1.5 million pound thrust engines in the Santa Susana Mountains north of the San Fernando Valley. So I had a tiny little role to play in the Apollo program, and I continued during the summer months to work for other parts of North American Aviation, including the Space and Information Systems Division. So I was already a big science fiction fan. I already felt like I wanted to see the Apollo program succeed. And so I was always excited about space exploration. Now, fast forward, in 1976, the US landed 2 Viking spacecraft on Mars successfully. That was a very big deal. First real long-term arrival on Mars. I think there were some earlier, might have been 2 earlier landers that the Russians were able to put on Mars. But then after 1976, nothing worked. For 20 years, every mission to Mars failed. And then finally in 1997, the US landed a small robot called, I forget what they called it, but it was the Pathfinder lander. And this little robot was able to drive around and deliver data back to Earth by transmitting directly from the surface of Mars to what's called the Deep Space Network. This is a network of 3 70-meter dishes, one in Goldstone, California, one in Madrid, Spain, and one in Canberra, Australia. So these big 70-meter dishes could receive a very, very weak signal from Mars. Literally the next year, in the spring of 1998, I flew out to the Jet Propulsion Laboratory, which had mounted that Pathfinder project, and met with a team that was interested in space communications. And we asked ourselves, given the success of that 1997 mission, what should we be doing in 1998 in preparation for what would be needed 25 years later? And we concluded we should be designing and building an interplanetary backbone network to support manned and robotic space exploration that had richer connectivity than just point-to-point radio links. And so we thought we could use TCP/IP to do that, but we were quickly disabused of that when we started doing the math. And we concluded, first of all, the speed of light is too slow, and the distances between the planets are literally astronomical. So at the speed of light, it takes 3.5 minutes for a signal to go from Earth to Mars, and of course another 3.5 to come back when we're closest together. When we're farthest apart, it takes 20 minutes one way, 40 minutes round trip, and I'll guarantee you that the TCP/IP flow control mechanisms don't work very well with a 40-minute round trip time. To make matters worse, the domain name system involves doing a lookup to find the translation of a domain name into an IP address. Well, if you're on Mars and you send a DNS lookup to Earth, it may take you 40 minutes or more to get the answer back. And by the time you get the answer back, it might be wrong because the device might be mobile and its IP address might have changed because it moved to a different radio network. So we concluded that the space communication environment involved variable delay, and disruption. And the TCP/IP protocols were not organized around parameter spaces that were that diverse. So we began designing a new protocol suite, which we call the bundle protocol. Those protocols have been, prototypes of those protocols have been running on Mars since 2004, when the Spirit and Opportunity landers arrived, and we discovered that we could not use the direct-to-Earth path and had to go through a relay. So we reprogrammed the rovers and the orbiters, which had been sent to Mars before in order to map the surface of Mars to figure out where the rover should go. We reprogrammed them to do store and forward relay. That's packet switching. That's what the ARPANET and the internet are all about. So we've been running prototype software for all of the Mars landers since 2004. And we've been running a standardized bundle protocol suite on the International Space Station for many years now, since the mid-2000s. So now we're at the point where we've standardized the bundle protocols with the Consultative Committee on Space Data Systems and with the Internet Engineering Task Force. We are running the latest protocols on the International Space Station, and we've made the protocols available to the Artemis and the Gateway missions that are returned to the moon. And of course, we hope to demonstrate the capability of the delay and disruption tolerant system in preparation for our moving to Mars, or at least visiting Mars, in the 2030 time period. So all of us who've worked on this have taken some 20 years to get to where we are today, but it's a very exciting moment now to see the possibilities of the future.
Yeah, and regarding Mars, do you think you're going to be like Elon, that's going to eventually live in Mars when you have the opportunity to do so?
Well, I'll tell you what, there is an organization, you've heard of the Internet Society, and you know that it has a number of chapters. Well, it also has special interest groups. One of them is called the Interplanetary Networking Special Interest Group. I started that in 1998 at the same time that we began work on the interplanetary internet design. I chaired that group for a while. Now someone else is chair, who happens to work for the Japanese Space Agency. We've just announced our strategic report about how the interplanetary internet could evolve over the course of the next 100 years in order to support not only manned and robotic space exploration, but also commercialization and industrialization of space. Now, it may take 100 years' time to get to the point where investments actually begin to make sense and the cost of getting into space has dropped down enough. But thanks to people like Elon Musk and others, and Jeff Bezos and Sir Richard Branson, the costs of getting into space are coming down rapidly. And so the possibility of industrialization is increasingly apparent. And of course, having a network to support that is going to be important. So if your listeners happen to go to ipnsig.org, you will see what our report is all about. And if you're interested, of course, we'd love to have you participate.